So today we're going to be talking about just some basic properties of exponents. So when we have an exponent, there's two parts to an exponent. We have our base, which is the bigger number or the normal size number. And then it's raised to an exponent. The power is a small number written in the upper right-hand corner. So for example, like 3 to the 6th power. Make sure when you're writing exponents that they are smaller, and in the upper right hand corner, if you start making them too big, this will end up looking like a 36 instead of a 3 to the 6th power, so make sure there's a difference there. And the properties of exponents that we're going to learn today will allow us to simplify these exponents when they have the same base. The same base, meaning they have that same number that's being raised to an exponent. It's like they would all have 3 to some power. Okay, so the first property is called the product rule. This is when you have two exponentials with the same base that are being multiplied. So if you have b to the n power times b to the n power, so they both have the same base, but they have different exponents. So when you have these two terms that are being multiplied, then the product rule says you will add the exponents. And it'll just become one term. So you add the exponents, base stays the same. So for example 1a, we have 9 to the 6th power times 9 to the 12th power. So again, they both have the same base, which means we can use these properties to simplify. And so to simplify it, we would keep the base the same, and we add the exponent. So this would be 9 to the 18th power. For letter B, we have x times x to the 7th. Now if I have a term here that doesn't have any exponent written, what is that implied exponent of this term? 1. So it's be helpful if you start getting into the habit of just writing that 1 there so you actually see an exponent. And again, we have the same base. They both have a base of x. And they're being multiplied, so that means we're going to add the exponents. So it would be x to the 1 plus 7 power, or x to the 8th. Okay. And then C, same rules apply. Even if it's a negative exponent, we'll be learning more about what to do with negative exponents in a minute. But in terms of the product rule, you would still, since they have the same base, and we're multiplying, you would still just add your exponents. So y to the 8 plus a negative 4. And so adding a negative 4 is just the same as subtracting. So 8 minus 4 would give us y to the 4th power. Okay, so that's the product rule. If you have two terms with the same base that are being multiplied, you would add the exponents. Now the power rule is when you just have one term, but it's being raised to multiple powers. So a power raised to a power. So if you had like b to the n power, and that was raised to the m power. So when you have this, when you only have one term and it has multiple exponents being applied to it, you would multiply the exponents. This would be b to the n times m power. Multiply exponents, base stays the same. Okay, so getting this one, the power rule and the product rule, is going to be easy to get those mixed up, knowing when to add the exponents and knowing when to multiply. So when there's two separate terms or multiple terms, that's when you'll be adding the exponent. If there's only one base, like there's only one base b here, but it has multiple exponents, that's when you'll be multiplying. Okay, so example 2a, we have one base here, x, to the fourth, and then that is raised to the fifth power, so we would multiply. This would be x to the 4 times 5 power, or x to the 20th. And letter B, if I have 5 raised to the third, and that's raised to the 7th power, again, we would multiply. So 5 to the 3 times 7, or 5 to the 21st. And so what would letter C be if we wanted to simplify that? Y to what power? 12. Multiply 2 times 6. You don't have to write this in between step with the multiplication if you don't want to. I'm just doing it so you can remember where those numbers are coming from, but as long as you have y to the 12th, that's good. Okay, any questions so far? All right, our next property is the quotient rule. Quotient is the answer to a division problem, so we're going to be dividing. So if you have two exponentials, again, they have to have the same base, and they're being divided, you're going to subtract the exponent. So it's like the opposite of the product rule. And it's always the top minus the bottom exponent. So you subtract the exponents, top minus bottom. And the base still stays the same, just like with the product rule. So example 3a, we have x to the 12th divided by x to the 4th. So we would, they have the same base and they're being divided, so we would subtract. So we'd have x to the 12 minus 4 power. So x to the 8th. And then letter B, again, we have in the denominator there a z that doesn't have an exponent written. That's that implied exponent of 1. So it'll be helpful, again, if you just get into the habit of writing that 1 there so you have an exponent to look at, because sometimes you'll forget when we're doing more of these, using more of these properties all at the same time. So since we have the same base, again, and they're being divided, we would subtract 7 minus 1. So z to the 6th power. And then our last one, letter C. What would my new exponent be for this? 10 to what power? 15 minus 8, which would give us 7. Yep. All right. So those are the three properties that are dealing with operations. So the multiplication of two terms, raising a term to another power, and the division of two terms. Now we're going to look at just some other properties that can help us, but it's really only dealing with one term at a time. So the zero exponent rule, when a term has an exponent of 0, it will equal 1, always. So anything raised to the 0 power is 1, no matter what that thing is. If it is raised to the power of 0, that term will equal 1. So 7 to the 0 power equals 1. Y to the 0 power equals 1. X times z raised to the 0 power equals 1. Anything raised to the 0 power is equal to 1. So that should be an easy one. And notice it's not like y to the first power. That whole term, y to the 0 power, became a 1. The y is gone. Okay, and then the last thing we're going to talk about today is negative exponents. When a term has a negative exponent, essentially that means the location of the term is going to change. So if it's in the numerator with a negative exponent, it would move down to the denominator. And if it's in the denominator with a negative exponent, it would move up to the numerator. So the location of the term will change. Again, we'll go either numerator and then back and forth between the denominator, just depending. So what I mean by that is if we have b to the negative m power, that would be rewritten as 1 over b to the m power. We just move it down into the denominator, and once we move it, the negative goes away. Its job is done. The negative exponent was just telling you, hey, I need to be moved. Once you move it, its job is done. Negative goes away. And the same thing happens if you start with a negative exponent in the denominator. This negative exponent is telling you this term is not where it needs to be. So we would move it up into the numerator. And when we move it, the negative's job is done, so the negative goes away. The number, the base stays the same. The value of the exponent stays the same. The only thing that's changing is where you're writing that term. And then once you move it, the negative goes away. But everything else about the term stays the same. Okay, so negative exponents just change the location. So example 5a, we have 6 to the negative 2 power. This negative is telling you that this term is not happy being in the numerator, so we need to move it into the denominator. So this will be 1 over 6 to the positive 2, because once we move it down, the negative's job is done. And so with letter B, this negative is telling you that term does not want to be in the denominator, so we need to move it up to the numerator. So x to the positive 3. If you want to still have the 1 there and have 1 times x to the third, that's fine. That's up to you if you want to write the 1 or not. Personal preference. And again, once you rewrite that term up in the numerator, the negative goes away. The negative's job is done. Okay, and then letter C. We have a negative exponent and it's in the numerator, so that means I need to move it to the denominator. 1 over y to the first. Or you can just have 1 over y if you don't want to write that 1 in the exponent. And then the last one, again going from a denominator to a numerator, would be 6 to the positive 4 power. If you want to write that 1 out in front, you can, but you don't have to. All right, I lied. There is one more thing on the back I forgot, sorry. Any questions so far, though, on any of the properties on the front? Okay. So on the back, rational exponents, this is just when the exponents are fractions. Rational exponents allow us to take a power, or to raise a number to a power, and to take out the root of a number. So when we have a number, a base, raised to a fractional exponent, whatever number is in the numerator, that is the power that the number is being raised to. So like b to the n power, just like we were doing before. But then if there's a number in the denominator, that is representing a root, so like a square root. So it would be to the 1 over m. It would be like saying the mth root of b. So remember, powers and roots are inverses of each other, so squared is the opposite of a square root. Cubed is the opposite of a cubed root. So these rational exponents, these fractions in the exponents, just allow us to say a power and a root at the same time. Okay, there are some common rational exponents, and this is, you're going to need to be able to type these into your calculator too. So if we have like x to the 1/2 power, that's the same as saying the square root. So it's the same as saying the square root of x. Remember when we have that root symbol with no little number written, like this is an implied 2 there, an implied square root. But since the square root is the most common, we don't always write the 2. And then we also have the cubed root. So that'd be to the 1 over 3 power. Okay, so mainly with these rational exponents, you just need to be able to go from writing the root as a fraction to writing it as with that root symbol. So example 6, if we have 121 raised to the 1/2 power, to rewrite in radical or root form, that means you have to have that root symbol in there somewhere. Since it's a 2, that means it's a square root. So we'd have just the square root of 121. So that's what I mean when I say rewrite. And it says we want to evaluate them. So evaluate means to plug it in the calculator. So with square roots, we do have that square root button in the calculator. If you hit the second x squared, remember that brings you the square root symbol, and then you just type your 121 and hit enter, and you should get 11 as the square root of 121. But if you don't want to use the square root symbol, you could type it in using the exponent form, where you would type 121, and then the caret button, that little kind of arrow is pointing up, and then in parentheses, the fraction 1 divided by 2. So that's the same thing. So whichever way for square roots makes the most sense for you to plug into your calculator, either one will work. They'll both give you 11. Okay, with letter B, we're dealing with a cubed root, though, now, because we have a 3 in the denominator. So when we rewrite it, we have the little 3 there, then that root symbol of 216. With cubed root, you do have to have that 3 there. If you don't write the 3, then we would think it's a square root, but it's not. It's a cubed root. Okay, so that's the rewriting part. Again, just rewrite. And then the evaluate. There's not a cubed root button that's easy to get to on the calculator. You can't use the same button that you use for square root because those are two different things. So for this one, the easiest way will just be to type it in that exponent form. So in your calculator, you would type 216. Good. And then the caret, which is underneath the clear button. And then a parenthesis, 1 divided by 3. Close the parenthesis and hit enter. And what do we get when we do that? Can you guys practice plugging it in your calculator so you can know what you're doing? You should get 6. Okay, so cubed roots, you're going to want to type in the fraction. If you want to just keep it consistent and do the fractions for the square roots, that's fine. Or if you want to use the square root button, the symbol, that works too. Any questions on how to type? Yeah. Any questions on how to type in this fraction as an exponent with the caret? Okay. Then our last one, letter C. Is this a cubed root or a square root? Square root, because it's a 2 in the denominator. So to rewrite it, we would have the square root of 81. And then to evaluate, again, you can either type in the square root symbol and then 81 in your calculator, or do 81 caret 1 divided by 2. And you should get 9. So again, rewriting it is just when you rewrite it with the root symbol, and then evaluating is when you plug it into the calculator. Okay, then the last thing is just going the opposite way. If I give you the root form, and we want to rewrite it as a rational exponent or an exponential form. So an exponential form means with a fraction in the exponent. So letter A there, we have root 25. Is that a square root symbol or a cubed root symbol? Square root, yes. Again, if there's no number written, that's that implied 2, that implied square root. So to rewrite it as a rational exponent, we'd keep the same number. 25 is still going to be 25. Then since it's a square root with that 2, the exponent would just be 1 over 2. Okay, and then to evaluate, again, you can plug it in the calculator the same way that you did. You can either use the square root symbol button in the calculator, or do 25 caret 1 divided by 2. So either way, you should get 5 when you evaluate this. Bless you. Okay, and then letter B. Is this a cubed root or a square root? What number is this right here? That's a 3, right, guys? So this means it's a cubed root. So that just means when you're writing your exponent as a fraction, it would be a 3 in the denominator. So you'd have 64 to the 1/3 power. And then to evaluate, again, this is a cubed root, so you're going to have to do the 64 and then the caret parenthesis 1 divided by 3. And what do you guys get when you plug that in your calculator? 4. Okay, and then the last one here, this again, we have that 3 as the root, which means it's a cubed root. So we'd have 8 to the 1/3 power. That's the rewriting part. And then to evaluate, you would do your 8 caret parenthesis 1 divided by 3 and hit enter, and you should get 2. Okay, so you want to make sure for these you will be asked to rewrite and evaluate, so make sure you're writing both things. Okay, do you guys have any questions?